Eric Darling here with Darling Data, and it is day 2 of headset hell here. At least as far as I can tell. Maybe it's still, I don't know what day it is. Where are we? Anyway, this video is about spurious left join logic. Over the years, of course, the many storied years of my consulting career, and before that, my many really impressive slew of DBA and developer jobs working with SQL Server, I have run into a lot of left joins. The logic of some of them is totally fine and sound. The logic of others is a complete broken catastrophe. And often, when you try to explain what is wrong with a left join, the eyes glaze over, the brain shuts down, and we go into a coma-like state. Well, it's almost like a medically induced coma. And then as soon as you stop talking, everyone wakes up and is like, "Oh, I don't want to smoke cigarettes anymore. You cured me." And you're like, "I didn't say anything about cigarettes." All right. Anyway, if you like this channel to the point where you want to contribute money in order to have it continue to exist, you can sign up for a membership at the link down below. It's very easy. For as few as $4 a month, you can put a smile on my face. If you don't have any money, perhaps something terrible happened to you. Perhaps you are in a medically induced coma and you have no job. You can like, you can comment, you could subscribe. I mean, I don't know how you're going to do that in a comatose state, but maybe I don't know. Maybe you can get a Neuralink in there and you can just pipe me into your every waking moment. And if you want to ask me questions privately that I will answer publicly during my office hours episodes, you can do that at that link, which is also down in the old video description. If you need consulting for your SQL Server, if you want SQL Server to go faster in exchange for money, I do that. And I don't know if you've heard this about me, but my rates are reasonable. Health checks, performance analysis, hands-on tuning of your worst queries, indexes, whatever situations you have, your worst situations in SQL Server, dealing with performance emergencies, and of course, training your developers so you don't have performance emergencies anymore. You can do all of these things and more with me. Hey, look at that. If you would like to get in on my performance tuning training, I've got about 24 hours of it. If you go to the link in the video description, that discount code will automatically apply when you buy the Everything Bundle, which encapsulates all of my performance tuning training. There is also a new course with new videos dropping daily that is called Learn SQL with Erik. That's me. And all of this content is, of course, available for $250 right now. When it's all published, it'll be $500. So, save yourselves $250 and get a subscription to the channel with the money you saved. Hey, look at that. We figured it all out. If you're attending Kendra Little and I's past pre-con in Seattle this November, you will, of course, get access to this content with your pre-con attendance ticket. You will not get it any other way. Even if you try to mug me in the hallway, you will not get access to it. This summer, I am doing a lot of stuff. I'm doing a lot more stuff than usual. August 18th and 19th, I'll be in New York City. Surprise! Well, I guess I'll be leaving the house, which is a surprise. And I will be speaking at the Pass on Tour event then, August 18th and 19th. In Dallas, I will be going even further away from the house, September 15th and 16th, for another Pass on Tour event. And then I will also be in Utrecht. Not just an art supply company, but also a place. It's a hamlet in the Netherlands, near Amsterdam. October 1st and 2nd, I'll be there. And then, of course, this all leads up to Pass Data Community Summit, which will be in Seattle, Washington, November 17th to 21st. We can have some pre-Thanksgiving joy and festivities all together, you and I. Won't be my birthday this time, but that's okay. I'll figure out another way to bully you into coming to our precons, I guess. Anyway, let's talk about these spurious left joins. Now, the first thing we need to do is set up some data, right? We need some tables. I am just going to use two relatively simple tables. And again, all thanks to Aaron Stellato for this lovely new connection dialog. Look at this thing. We're going to connect right into Stack Overflow 2013. Not that it matters because we're using temp tables, but we might as well be in our home database, right? So we have this first table here called T0, which is just going to be a simple one-column table. Nothing much to see there. And now we're going to have a table called T1. And T1 is going to have a few more columns in it. I'll explain those in a minute. It's also going to have another index on it. I'll explain all that right now. So we have a column called TID. This is what we're going to join back to our other table with. We also have a column called summer, which is where we're going to sum values from this column. We have a column called dater, which is going to have some dates in it. And we have a column called date override, which we're going to use to say, hey, maybe we don't care about what date is in here if we're overriding the date. And then we're going to have an index on the columns that we're going to be like joining off to. Because right now we've got this clustered primary key on the ID column, and that's not really going to help us join if we have other things going on here. That's not going to help us at all. So we're going to add an index to do ourselves a little favor. Now, since tiny ints, and remember this column is a tiny int up here, the tiniest of ints, we are going to insert 255 rows into T0, and we're going to use this wonderful generate series function. Then we are going to insert 25,550 pseudo-random rows. And actually, something I'm going to do here is turn off IntelliSense because IntelliSense is giving me all these red squiggles that are just straight up misinformation. They are lies. Nothing going on here is at all red squiggle worthy. But we're going to put 25,550 rows in here. We're going to repeat our little modulus math here so that we only get the numbers 1 through 255 so we don't overflow our tiny int. We're going to put some completely random integers into our column called summer. Remember, we're going to sum these up. And then we have our dater column. And our dater column is going to do a little fizz-buzz. And we're going to say when the value that comes out of the generate series function is divisible by 15, or modulo by 15, then the mark is going to be null. When the modulo of 5 is 0, then we're going to put in the date 1900-0101. We can pretend that that's some other that has some other meaning in our database. When the modulo math on 3 gets us to 0, we're going to subtract 90 days from the current sysdate time, and otherwise we are going to convert the current sysdate time to a date, and we're going to add a minute to it. The reason I'm doing this is because I don't need dates that go a billion years into the future. I just want to like have some reasonable dates sort of around like today. So it just so it makes a little bit more sense. So adding minutes to a date, of course, has no effect. Like we're adding minutes to this. So eventually, like in a whole bunch of minutes, we actually will get a new day out of, for the date. I don't think with 25,000 rows, I don't know if we're going to get a new month. I guess it depends on how close to the new month you are, right? But this is going to get us some data in here, and we're going to join table T0 to table T1. All right. So did that actually run and do anything? I'm confused. It did. All right. Whew. All right. Now we have to masseuse this data a little bit. We need to do some things to this data, right? Like we're going to delete some rows from T1. Specifically, we're going to delete any rows with the TID 5, 10, 15, or 20. I only do this because rows 5, 10, 15, and 20 show up really early in the results, and I don't have to scroll very far to show you where things get weird with this, right? So we just deleted 400 rows from this table. If we run this again, we're going to delete 0 rows. All right, now we're going to update the table, and we are going to set the date override bit to true, where the date column is greater than 1900, and where the dater column is less than or equal to 90 days from today. So remember, some of the columns we set back in time, and then we're only going to do that where the ID, the modulus math on the ID, divisible by, moduloed by 2 equals 0. All right, so we're going to run that there. If you're wondering why there's a return statement here, it's because when I was working this up, it was very easy for me to just like hit execute and have everything stop here after all like the data reloading stuff, and then I could just get into the queries. So let's say that we're going to start with an example query that has no spurious left join logic to it whatsoever, whomsoever. And I just want to show you what the results are. All right, so we run this. We're going to get back some stuff. Note that since this is a left join, the goal is to preserve all the rows on the left side of the join. An easy way to think about that mentally is to take the join and put it up here on this line. If it's a left join, we want to preserve all the rows over here on the left side of the join. Sorry, over here on the left side of the join. If this were a right join, we would preserve all the rows over here on the right side of the word join. Okay, so pretty easy. Our goal with the left join is to make sure that all the rows from T0, regardless of a match occurring in T1, remain in the output. And we get that with this. So like remember when we deleted rows 5, 10, 15, and 20, we just get some nulls back for those, right? Null, 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 right? This is exactly what it's supposed to do. It's wonderful. We have some null dates in here because remember some of the rows we set up above to say, hey, this date needs to be null, right? So we did that for a few of them. Now, our query logic, the goal of our query logic is to maintain the left join to T0, but we also need to do some stuff. We need to not sum anything with the date of 1900-0101, and we need to not sum anything where the date is less than or equal to 90 days from today, with the date override being 0. But we do, when the date override is 1, we do want to sum these. Okay, these are valid for summing because they have the date override. All this while respecting the left join semantics. All right. So what I always see people doing, and this is where the spuriousness comes in, this is where the spuriosity begins to emerge, is you'll see someone write a left join with an incredibly permissive where clause and a hell of a lot of parentheses in order to try and preserve all these nulls, right? And if we run this, even with this incredibly permissive where clause, with all of these null allowances, we are still going to be missing some rows in here. If you notice, we're missing some rows in here like 6 and 7. We jump right from TID 5 to 9, and then 10, and well, there's no 11, and there's no 13. So we did not preserve all the rows from T0. Now, the plot will thicken even if we add this in, right? So we're gonna include this, and we're gonna run this query, and we're gonna get more rows back, but we're still missing some stuff. If you pay real close attention, you'll see that we're still missing some rows like 6 and 7, and 11, and 13. And let's see, 15, 16, 17, 18. There's no 19. Oops, that wasn't a square. There's no 19. There's no 21. We got 22, 23. We're missing 25. We still, even though this query technically does still do a left join, at least I think I remember it's still doing a left join. It does. Even though we do this here, this filter removes rows. Now let's backtrack a little bit. All right, just a wee bit. Let's backtrack. When we run this left join without any spurious where clause stuff in it, and we look at the execution plan, we get a right outer merge join, which I'm going to not pass any judgment on, but we return all 255 rows from T0, which is what we want. If we rerun this query down here, even with this extra bit of permissiveness in our where clause, actually what I want to do is take this out first and show you what SQL Server does. Because if I remember this correctly, it's been a few days, but I think this is the one. Oh no, that's not the one. Never mind. Before this thing was giving me an inner join on something, but we can forget that part. But anyway, let's run this, and we'll show you this again. We have our left outer join right? And everything is going well until about right here, when we only return 187 rows of the 255 that we should be returning. Like we this right here, 255 rows. We need all of these rows preserved. We are not preserving left join semantics with that where clause, regardless of the absolute permissiveness of this thing. It's like where this is null, or this is 0, or this is null, and this is greater than this, or this is null, or this is 1, or this is like, we have gone out of our way to say, hey, really, just show me everything. We've done everything except write the query correctly. Right? We have not fully preserved our left join semantics. Remember that the general shape of our results should still match this one, where we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way down through 255 down here, right? We are not looking for 187 rows of results. We are looking for 255 rows of results. So what I want to get across here is that most of the time when you have a left join, and then you stick a bunch of stuff in your where clause, no matter how permissive it is, to try and say, this can be something, or it can be unknown, right? We can have a null mark in there. It can just be whatever, right? Well, I'll take anything you got. SQL Server still ends up filtering stuff out. Now, let's look at writing this query in a few different ways in order to see how we can get the correct results, but also preserve the actual left join semantics. One of those ways is to not write a big stupid where clause on our table. Yuck, gross. One way is to put the logic that we care about in our join clause. So we can say, join on this and, hey, this stuff. And when we do that, boy howdy, look at what we get back now. We actually get back all the contiguous numbers that we cared about. If we go look at the execution plan, we get back the 255 rows that we want with the logic that we want applied to them, right? We have not mistakenly removed any rows from the results. We have preserved the left outer join logic. We can extend that a little bit, and we can say, hey, let's write this as a scalar subquery in our select list. Now, if you've watched my other videos about scalar subqueries, you'll know that these cannot remove any rows from results. They get treated like a left outer join. We can still write this, and we can have a where clause in here that correlates the table the table from the outside, which is the outer context, which is T0, to the table in the inner context, which is T1, and we can still get the correct results from this, right? We can't get all the other columns that we got back because the scalar subquery can only return one column, right? And like one row per thing. But anyway, if we look at the execution plan for this, we once again get a right outer join and return all the 255 rows that we care about. And the results are what we want. Now, another way to think about this is with outer apply. When you write outer apply, you can still have a where clause, and you can still preserve left join semantics, and you can actually return a whole bunch of columns with outer apply. What a useful little apply you are, right? Outer apply is more like a left join, and cross apply is more like an inner join. So we can put all our filtering stuff in here and get the correct results back. And if we go look at all this, granted, there's a lot of nulls in there, but like that's sort of what we're asking for, is like we're going to sum this stuff sometimes, and we're not going to sum it other sometimes. But looking at the execution plan, well, now we have a nested loops left outer join, but we still get all 255 rows back, which is what we're after. We need those 255 rows. Putting a where clause on our left join kept restricting the rows down to 187. It was not a good time. Another way of looking at this is, what if we did our left join to just a query in here, and we selected all this stuff, right? And what if we run this? Is this going to be correct? What will the execution plan tell us? Indeed, we got back our 255 rows. So all of the other ways of writing this query allowed us to sort of like stick to like maybe having a where clause in there. Like it satisfied our innate desire to have this be a where clause, but it also preserved the outer join logic of having all 255 rows from T0 show up in the results. So whenever I see, like I said, whenever I see a left join with a where clause and it's all full of is null or and maybe this if kind of, well, sometimes may, oh, well, not that, but yes, definitely this, I get nervous that whoever wrote the query had no idea what they were doing and that where clause should have been an and clause in the join clause. Anyway, thank you for watching. I hope you enjoyed yourselves. I hope you learned something. And I will see you over in the next video where we will talk about something else equally magnificent. All right. I'll still be wearing a headset, but we're going to do it. Anyway, thank you.